Yeah, I have to can now introduce Jimmy Bogard. He will talk about himself and domain-driven refactoring. And yeah, take the stage.
All right. No, that's not necessary, please. All right, thanks for coming, everyone. There's my information if you want it up there. I come from the Microsoft .NET C# world, so if you're from that world too, you may know me from the stuff at the bottom. If not, don't worry. Today, the talk is a live refactoring example. It is done in C# .NET, but it still can apply to really any language, because any language that supports refactoring, well, this talk can apply to. The reason why that's I really like this talk is that a lot of my clients in the consulting world don't start off with like just completely blank slate DDD style projects. They have a bunch of existing legacy code, and they come to the table assuming that, well, DDD is great and all that stuff, but don't you have to start with this like big design session and modeling and all this stuff, and you're at a whiteboard for like a year before anything comes out? And the truth is, it's not the case, that you can start with an existing system and move it towards domain-driven design. And the way that we can do that is through refactoring techniques. Now, this is a DDD talk, or a DDD conference, so I probably don't have to cover this, right? We don't need to be taught, like, what is domain-driven design. I do give this a talk quite a bit at places that have never heard of these terms before, but I assume that we've all heard of these, so we can just skip past this part. Now, we'll be mainly focusing on the domain model itself. So refactoring from an existing system that doesn't have any concept of domain models and trying to move towards it. And this one in particular, we'll be looking at an object-oriented flavor of a domain model. So this would look quite different if we were in a functional style or functional language. But none of my clients want to do that, and so I have to worry about the sort of OO side of things. But what we're trying to do is try to build towards that domain model that is, fully encapsulated, incorporates both data and behavior, and not just data by itself, and try to get towards that, the ideals of the aggregates and entities and all those sort of things. But most of my clients, their existing code isn't that, right? It sucks. It's like just a bunch of procedural code, spaghetti code, like you've got all these kind of helper classes and static classes, and just not in a good spot for them to look at and say, yes, what a nice, clean domain model. What they should have been doing, though, of course, was this traditional kind of TDD steps of red, green, refactor. Although most of my clients don't have tests, so it's like just, well, we have a couple tests, but they started failing, and so we just sort of commented them out or put like a skip attribute to say, someday these sort of tests will pass. But they also, even if they're doing TDD, they'll skip this last step. They never come back to actually refactor their code to try to figure out where that behavior should be in their system. I also find as well that even if we try to put sort of like kind of like rigid rules about where behavior is supposed to be, inevitably it won't always fit into sort of the clean separations that we typically find. Like, not every line of code necessarily needs to belong in an aggregate, for example. There are going to be cases where that behavior shouldn't belong there, and we still need to use these refactoring techniques to understand, well, if it doesn't go there, where should it go? And then how should we organize, how should we factor that code? Now, luckily, this is not the sort of thing that we need to invent for ourselves, that we don't have to just come up with all these techniques whole cloth. Instead, there are a lot of great resources out there in order to use basically code smells and refactoring techniques of those code smells to push ourselves towards a domain model. I also found that even if I'm not like explicitly trying to set out to create a domain model, if I use these sort of standard refactoring techniques that have been cataloged and defined for decades now, what often ends up at the end is that domain model. So my favorite books around here are, of course, the kind of canonical Martin Fowler refactoring book. The original one was Java, and the new version is TypeScript, which, whatever, but it still works for me. There's one that's actually out of print, which is unfortunate, but it's my favorite patterns book. I still use those, especially the behavioral patterns. The one on the right, the Refactoring to Patterns book, but also the probably the most poorly named book I've seen. Working Effectively with Legacy Code, which if you have on your desk and your manager walks by, they're like, is that about our code? And you're like, no, 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 we're not legacy code. This is all great stuff. But that also has a lot of great techniques on how to introduce seams and how to take kind of code that doesn't have tests today and how to safely move it towards classes that can be tested. And classes that can be tested just coincidentally happen to fall kind of neatly within the objects and kind of primitives we find in domain-driven design as well. So with these, both the code smells and with refactoring techniques defined in these, we can move our existing sort of legacy code towards a domain model. Now this example I'll be covering today is actually from a client project I worked on years ago, and is really where I came up with this talk. Was we had an existing code base that sort of modeled this idea of an anemic domain model, in which we had objects, but they only had states and they didn't have any behavior. And so the current state of this application of this system, in this case, it was modeling one of those like loyalty rewards programs. And this is one we did, I say we, that's like the royal we, it wasn't me, it was someone else, of course, because I would have created the perfect domain model to begin with, of course. So these folks, they did try to go through the part of working towards a ubiquitous language and making sure like the names and relationships of things did match to what the concepts and ideas that the domain experts had in the real world. And so we had this kind of starting domain model, although I wouldn't even call it a domain model, it's really a data model because it only has data. Because if you look here, we've got a set of entities. We've got a member, an offer, and an offer type. And these concepts do match exactly to the concepts that the domain experts have of this loyalty reward program. We have members of the reward program. They're not called people or humans. They're like, no, that's too broad. I have to opt into this program. And so if we do that, then you become this member thing. And members are members of the reward program. Members can have offers assigned to them, and those offers assigned to each individual member and can't be assigned to anyone else. So when they redeem that reward, then it goes away for that person, but someone else can have their own kind of instance of that offer. And then finally, we have metadata about different kinds of offers. So you can kind of imagine there's some management utility somewhere where they're dreaming up different offer types with different kind of attributes associated with them, and the marketing department just kind of goes wild over there. So I could show this picture to the domain experts, and maybe not this exact picture because it's still got too much kind of weird annotations and symbols and junk on it. But they could look at this and say, yeah, this matches how we conceptualize our different kind of things in the real world as well. We have members, we have offers, and each offer has a type. Even the associations between these different objects represents the associations in the real world. So instead of something like a member has offers, well, that doesn't represent the relationship or the kind of how are those offers relating to that member. So we say, well, they're assigned to that member. They're not just a collection of random offers here. So we can show them this picture and say, yes, they agree, like, yep, this looks good. We can put this up on a whiteboard, and everyone agrees that this is, at least for the state of the system, this matches how they expect the state to work and the relationships to work. There's a problem here, though, in that in these objects and these types, there's only data, and there's no behavior. So in this system, the system does have behavior. There's code in my system to be able to manage these relationships and manage the kind of state changes I can have in the system and all those sort of things. That behavior exists, but it's not represented in my domain model, but it's somewhere. So where is that behavior? Well, it depends, right? A lot of times you'll see it if you're doing kind of MVC style or APIs, it'll be in the controller actions. Right, it'll be this long controller action, and in the middle there is all the behavior of the system. Maybe they got too messy though, and so instead of putting it in the controllers, you're like, well, we'll move it out to somewhere else, and those will be helper classes or managers or something service. And so you have these very generically named objects that have all the behavior in the system, and usually they're kind of centered around a specific noun. So I'll have I have a member object, so I'll have member service or member helper or member manager or member service. It'll have just the name of the thing, and here's just a dumping ground of all the behavior in the system in one giant file. So it won't exist in your model. It'll be somewhere else in your system. So what I like to do is take that something else and just using sort of standard refactoring techniques, slowly move that behavior out of these places outside of the domain model and then move them into the domain model. Now, here I say it's called services. These aren't even domain services. These are just like just the dumping ground of junk, like the junk drawer, where you put all the behavior in your system that's, that kind of just builds up over time. So let's go ahead and switch over now to my IDE, and we'll cover the actual behavior in the real code. So let me go swap to mirror. And is this big enough? Let me just open up the code here. Come on. There's always a little handoff here. And there we go. OK. Is that big enough for the folks in the back? The font size? Or is it too big? Like sometimes these rooms are really long, so let's bump it down a little bit. This is a little too much. OK. So yes, I have over here my model with, here's my quote domain model, but it's not a domain model, it's just a data model that only has data, no behavior. If I'm trying to do DDD and I have a model that only has data, then it's no longer a data model, it's one of those bad anemic domain models. And so that's all the classes that just have the properties, but no actual behavior itself. The behavior is in these other things. So I've got one of these other things, and this at least represents a single kind of service class that represents the behavior of assigning an offer to a member. And in this class, it does represent kind of all the things that you need to do to be able to perform that activity. And when I'm first starting to refactor, one of the first things I do is I look at the kind of the using statements at the top, all the namespaces I'm importing, and that tells me kind of what are the things that this class relies upon in order to do its work. And that also tells me like how many different things are going on to understand like what are the different kinds of external dependencies I'm pulling in here. So I see that I am using systemnet HTTP and system text JSON, so that kind of clues me in that I'm probably calling out to some web API to do some work, and then doing some deserialization from the JSON to something else, or serializing one of the two. I can't be using modern languages without async, so async await, so there's async await junk. And then there's, of course, using my quote domain model that's not really the model. And then this is just the kind of the service class that all my logic is going into. The next thing I look at is then the controller. The constructor here. So this application is using dependency injection. So I can see that the constructor arguments tell me what this class depends on, and also tells me what this class requires for it to do its work. So I see here that it's using this right here is, by the way, how many here are .NET folks in the, like half, and then the other half like Java folks, I guess? Yeah, OK, so just like substitute hibernate for any framework, but it's roughly the same. Like you can kind of squint, and it basically looks the same. If you're doing functional stuff, then like none of this applies to you at all. Just do functional stuff. Yeah, so I can look at the constructor here and see it's using this DB context, so that's the ORM junk, and I can also see that it's using an HTTP client, which is going to be the web API junk. All the logic to perform this work is in a single method. One of the things I often do with these kinds of exercises is sometimes the developers that have come before me, which could have been me as well, have gone through a kind of refactoring already. So sometimes what I'll do is do a defactoring exercise. And a defactoring is sort of the opposite of refactoring, in which I am like removing all this stuff and trying to get it into like one single method so I can just take a look and say, well, this is all the junk that's happening here. This one hasn't done that yet. It's just put everything in one single method, so I can kind of see like this is all the work that needs to happen in order to perform this action. All right, so let's just look at this kind of step by step. What's going on in this method? The first couple lines here are just data access stuff. So this is nothing too exciting here. If I'm assigning an offer to a member, which is represented by this individual DTO or kind of single request object, I can see that it has, and in order to assign an offer to a member, I need to know who the member is and what offer I'm assigning. And so that's represented by this thing. Just a DTO saying member ID, offer type ID. In my my first couple lines here, then I'm using that to pull out those not entity, well, I guess they're entities for now, from the database so that I can do some mutations here. Now it looks like this method got a little too long, and so you can see that the original developer tried to help out themselves by adding in some helpful code comments to try to break this method up into like the different major steps that are happening here. So the first major step that happens is to calculate the offer value. And we can see here that it's calculating the offer value by calling out to some API. The API doesn't actually exist, so this code doesn't actually run at all. But let's just pretend that there's a web API out there somewhere whose sole purpose is to calculate offer values based on who the member is and what the offer type is. In our real system, this was like some CRM something or other that like knew who bought what, and like if you were a super shopper or something, you got a better offer deal or something. Doesn't matter. The end result is after all of this set of code, we can see that we get a value that is the value of the offer. Next up, we have a method to calculate the expiration date. And so it looks like that's, again, got a little bit of a complication there in that there's two different kinds of expiration types. And based on if it's a fixed expiration or based on a certain number of days from today, we can calculate the expiration date. And once I have those two pieces of information, the expiration date and the amount or the value of the offer, now we can assign an offer to a member, which is then this last little bit of code here. Finally, so that's like what I can consider the sort of like the real business logic of this method is getting this like this calculated data and then performing that last bit of logic to then go, okay, let's assign this offer to the member. And it looks like there's even more logic that goes on that says, okay, we're keeping track of the number of assigned offers, and so we have like this extra bit of calculation that happens there. Finally, there's more data access junk. And this is probably, if I'm looking at the writes in my system, this is 99% of what they do. There's read the junk out of the database, do some sort of business logic, and then finally write the data back. From a refactoring perspective, it's the middle part that's the most interesting. I don't really care as much as about like the reading the data and the writing the data. That's more just sort of infrastructure concerns. It's really that middle chunk that is the interesting part of my system. So if I look at this, and I can see that I have to scroll a bit to go through this method, and that tells me that this method is too long. So one of the first things we can do is to extract individual methods out of these major steps that are happening, and this will give some more insight into the nature of each of these steps. So let's do that first. And by the way, I'm using, this is Visual Studio, but I'm also using JetBrains tool called ReSharper. This is not a JetBrains advertisement. I don't get any money from them, although I should, I guess, because I keep talking about their stuff. I'm only using them because I've used it for like forever, and I cannot refactor effectively without like a good, strong, sharp tool in order to do so. But otherwise, like if you're using Java or TypeScript, whatever, like the JetBrains tools will do all this sort of stuff as well. All right, so for this part, I'm going to extract a method. And it'll ask me what I want the name of the method to be. Now, the name of this method, I can use the code comment above that says calculate offer value. Like, well, is that good enough for my name? I kind of think so, so I'll call it calculate. And as you see me typing things, I will suddenly forget how to spell everything, just kind of heads up. And then in terms of the order of the stuff, they're kind of order of importance. So member goes first, then who am I assigning it for? And then finally, of course, async always has to have a cancellation token. All right. So that has figured out what are the inputs to this method. It has figured out what are the outputs. And if it's using any kind of like dependencies, those will be used inside this method as well. We'll do the same thing for the other two as well. So we'll just go ahead and extract a method for that. This is calculate expiration date. And finally, assign offer. All right, now this kind of intermediate step is important for us of extracting individual methods inside of this overall class, because I'm eventually trying to push this behavior down into my domain model itself. But it can be difficult to figure out where exactly it should go just by kind of like just looking at the code by itself. So if I break this up into smaller chunks, I can see what each of the smaller chunks, like what the behavior they're doing, what they depend on, and that'll give me that clue and that insight. So where should this behavior ultimately live? So let's look at each of these methods one by one and decide where should this behavior go. So the first one I have is this calculate offer value method. And in terms of choices of where this behavior should go, I have my aggregates and entities themselves, or I can decide to make some kind of new object, which would then be a domain service. So something that is not the domain model itself because it's more stateless and doing work kind of around the aggregates, or I can push that down into aggregates and entities themselves. The way I can decide this is by looking at what the method is doing and what it depends on. So I can see that this one is taking a member object and an offer type object, but it's also leveraging this HTTP client thing, this web client that's calling out to some external API. So in terms of like where this behavior should go, it would be a little odd to put this down into the member object, because that means that member object is calling out to web APIs. And that's a little weird. Like my aggregates calling out into crossing network boundaries and things like that. I tend to try to want my aggregates to not do that sort of thing. So if it's not an aggregate or an entity, then the next logical choice is going to be a domain service. So the way we can do this is I can extract a class from this, and ReSharper is going to do do a set of analysis to figure out how can I extract this class or this method into a separate class? What do I need to do to make that happen? So the first thing I'm going to do is give it a name for this. And so this method is called calculate offer value. And so if I wanted to name this as some kind of object, I would call it the offer value calculator. It's got a couple warnings here to say, hey, it's using this private field. You got to do something with this. Either it needs to be like it's passed down to that object, or you can make that field public and then it can call. And that would be really weird. So what I'm going to do is I'm going to extract this out into a member on my target class. The next one is it says, well, this method is private. We're going to make it public because moving this method and extracting a class from it, well, now it needs to be public so it's visible to the calling class. Once I click next, the method magically disappeared. Well, not magic, it's ReSharper. And then it created this class for me. I have now an offer value calculator that has the guts of that method that we see here. I do double check this sometimes because sometimes it's not just using text-based approach to pull methods out. It is using the lexer parser to figure out the code behind the scenes to try to extract this out as effectively as possible. All right, if I go look at the usage of this, we can see here that it's actually still passing in the same HTTP clients, except now it's newing up this offer value calculator directly inside of here. That's not typically what I want to do, right? If we're wanting to make this class testable, I don't want to necessarily depend directly on an HTTP client. We'd probably want to have an interface that encapsulates this behavior. So I can do that, again, with ReSharper. So I'm going to extract an interface for the calculate offer value method. And now I have an I offer value calculator. And then down here, instead of being an offer value calculator, I would want the interface instead. So I can do this by this is where I have to find where the right kind of helper method or the helper dialog here to get the thing I'm looking for. So let's see. I actually want this to be. Nope. Okay, well, I want to make that an I offer value calculator. There's a refactoring there somewhere, but I can't always remember exactly the way to get to it. So I don't want that to be an I thing or the concrete type. I want it to be an interface. So if I want to kind of mock it out or stub it out in a unit test, I can do that. There aren't any unit tests over here, so I will caveat to like, in real life, please do like add tests as you go. Like leave the code better than you found it. But for now, we'll just leave that as an exercise to the reader here. All right. The next thing I want to do is I don't want to have this come in as a parameter, this HTTP client. I want that to be coming in as a constructor argument instead. So I can do that by introducing a parameter, the offer value calculator. And one of the other cool things about ReSharper is it tells me that, hey, because you're doing this, then you can actually remove this parameter altogether because it's not being used anymore. So I click next. And this is a warning saying, hey, no one's using this constructor. So if anything is trying to set up that value, it's going to get screwed up. So, offer value calculator equals offer value. OK. So I would want to go into my DI configuration over here somewhere to say, go ahead and add the, go ahead and configure that constructor argument effectively or appropriately based on however it was getting set up before. OK, so yeah, I've now created this domain service, which is an offer value calculator that it encapsulates the calculation of that offer. It's doing some HTTP client stuff behind the scenes, calling an API. But that's all well and good. Well, that was kind of the easy part, right? I had a set of code that was stateless and used some external dependency. So it was really easy for us to say, well, just extract an interface for that out and put an implementation that does the original thing. Next, I want to look at these other methods. And this is where we'll start to find logic that doesn't belong in an external or in a domain service, but really should be pushed down into our domain model itself. So let's look at this first one, calculate expiration date. Now, the first thing I can notice here is that whenever the developers wrote this, there were a lot fewer features of C# to leverage here. And there's a little doodad here, I think that's the official name, that says, hey, you don't have to use this switch statement. You can actually use a switch expression. And when I do that, and I say, well, this is, that's now going to an expression-based switch statement or switch versus a statement-based switch, which also means that this expiration date, the calculation, I don't need to have that anymore. Like it's just assigning the variable and then returning it. So I can go ahead and inline that, and now it just returns it. And then I'm in still C#, so I can even go to expression bodied members. It's now that whole switch statement, with there's several lines of code, now just becomes a single expression. I do this quite a bit, especially when looking at kind of simplifying code that will maybe move me towards a more kind of immutable sort of style. Is if I can get things to be kind of single expressions, it's much easier to move towards that immutable style domain model as well. So in this case, we have now a single method that represents the calculation of the expiration date. And now I want to look at the contents of that method and understand, well, where could this behavior belong? Now, one of the things that happened when I extracted that method is that ReSharper knew that I wasn't using any dependencies, that I wasn't using any of the instance fields of this class. And so it actually wound up making this method static. And that's kind of handy because that tells me that this doesn't need to use any external dependencies to perform its business logic. All of the business logic is encapsulated inside this one method, and all the stuff it needs to do its work is in the incoming parameter. So that tells me that, hey, if I'm looking for a place for this behavior to belong, why can't we move it to the offer type object? Because everything inside of here is dealing with that offer type stuff. And the code smell, which I think should have a better name, is called inappropriate intimacy, which is like one object like poking around at another object. And so that's what we see here, is that this method is awfully concerned with this other object. So why can't we move this behavior to that other object? Now there's a slow way of doing this for me with ReSharper. I'm going to do the fast way, which is to down here, there's a refactoring called make, and I can't make that bigger, I'm sorry. It's called make method non-static. And if we're making a method non-static, that means we're making it an instance method. And if we're converting from static to instance, then all these places that are calling into some kind of instance of something will now be represented on that object itself. And it's easier to see this than we talk through it. So let's see it in action. Make method non-static. And so what ReSharper is going to ask me is, OK, you've made this method non-static. Are you wanting to make this method non-static? What is the method instance parameter that you want to be the target of where this behavior should live? And so I say this should belong on the offer type parameter and then the offer type object. So I click next. And again, the method magically disappeared. And it landed over here on the offer type object. So now I've got a calculate expiration date object or method on the offer type object that has that behavior pulled over. But notice that it has modified all of the parameter-based usages to now the instance-based usages. So it's not offer type dot expiration type, it's just expiration type and done. This is, again, one of those things that, like, if I was doing this manually by, cut, paste, I would be stuck with a bunch of compile errors. ReSharper just kind of, and JetBrains in general, will kind of skip past those compile errors to code that actually works. It's much safer. OK. Now, if I go back and look at my original class here, that method went away. But now, it's also replaced the usage of that to use the instance-based version of that method versus the static method that we saw here earlier. And why don't we also get rid of these code comments? Those are providing no value whatsoever. OK. So next up, we have the assign offer method itself. So let's look at this one. So right off the bat, one of the things that I tend to notice here is that it's using an object assignment. No, what is this called? I forget the name of this expression, but it is the initializer. There we go, initializer-based way of constructing something. And the trouble with those initializers is that oftentimes you have to make everything public to make it work correctly. And so for this one, for example, I can eliminate all of these values, and I can still create this offer. So one of the things I often try to do is to say, well, we don't want to make it to where anyone can just create anything with invalid state. One of the ideas behind domain models is that they should enforce invariance, and that includes what it takes to create one of these things in the first place. So I can do all sorts of crazy things here, like offer dot member signed equals null, which if I went to the product owners and the domain experts, can we have an offer that's not assigned to anyone, that's just kind of floating in the ether? No. You have to assign that offer to a member. In fact, the offer can't exist unless it's assigned to an individual member of this loyalty program. Right now, nothing in my code enforces those invariants. So right away, what I'd like to do is modify this to enforce those invariants on construction. Now, there's not a great refactoring for this, unfortunately, because it would require too many steps. So what I can do instead is create a constructor that will accept all of the appropriate parameters, and then I'll have to go back and fix all my code where it does all these things. So here I see I have the member assigned, the offer type, the expiration date, and the value. And if I look at the types of these in C# land, we can have nullables, which are similar to maybes in functional languages. But none of these are modeled as nullables. So that means that I have to have a value for each of these things. I would often go to my domain experts and talk to them well, what is required for all these things? Or maybe even just look at the database, because oftentimes someone has already gone through this sort of modeling, but from a very data-oriented perspective. And I can look in the database to say, well, is the database enforcing these invariants as well for construction of these things? And they might tell me yes, you need all these different things. I could check parameters for null if I wanted to throw argument exceptions. Well, let's just do that. Why not? OK, so we've created a constructor that accepts all those values and enforces that if you're going to construct one of these things, you have to provide each one of these individual values. And the code itself will not compile unless I do that. So over here, I get my little red squiggly. So let's go ahead and put all those things in here. I need the member, I need the offer type, I need the date expiring, and I need the value. Now, there are capabilities in later versions of C# that still allow us to have that initializing style of creating objects. So I can make these as init properties, which would allow them to be only added at init. But it still makes it difficult to like throw exceptions if they don't exist. So I still prefer to change these to be all private setters to enforce that you have to go through sort of the front door to be able to set any of these values. Okay. So this offer object now looks okay. Now, one of the things I did notice here is that this right here, that line of code right there, is just sort of hanging off to the side, and it doesn't seem to be like the same conceptual level as the other methods. Like this one seems to have quite a bit of logic in here, and this is just a line of code hanging out doing nothing. So as I go through this refactoring process, I'll often do a bit of defactoring to like, okay, I've done one set of things, let's go ahead and undo some things so I can get another kind of big picture view of what's going on. So my defactoring here will actually be to inline this method. So when I inline it, and there's just one funny thing, but we don't have to have something called offer1. That's just ReSharper trying to be extra safe with mutability problems in C#. So just ignore that weird offer1 equals offer. Just pretend like that didn't exist. And so now I'm looking at, okay, well, initially, I had these lines of code that were just kind of stuck to the side and this one over here. So what I'll do now is re-extract a method for this stuff. Assign offer. Okay, so now I basically just moved the calculation of the expiration dates over to this individual method here. Okay, so now we're looking at our sign offer. One thing I also noticed, again, is that we are calculating the expiration date, but this value is only being used to pass through over here. But this other parameter that it was using to calculate is also being passed through. So this looks like to be somewhat of a waste of time to create this intermediate variable that is then just being passed through. And from a behavior perspective, to create an offer, I can't calculate sort of any expiration date here, like date time dot max value. Like I shouldn't be able to pass in whatever I want here. It should be using the type of the offer to calculate the expiration date. It shouldn't just allow any sort of value whatsoever. So the way that I can enforce that is to encapsulate the calculation of that expiration date inside this constructor. So we can do this by first inlining that variable. And now when I go to the offer object, I can inline this expiration date. So it's going to say, you don't need this anymore. And so got rid of that parameter and replaced the value that it was using with that actual calculation. I'm going to undo that and do it again because it was a little fast. So if I undo it, back over here, so ReSharper sees that this is the thing that I'm using this is the value I'm using to pass in. So if I want to inline that parameter, ReSharper is going to look at all the places that I'm passing that value in and then say, how do I replace what you were doing before with code inside of my constructor instead? It's just that smart to be able to do so. So I'm going to, again, refactor, inline parameter. And if you have problem, like if there are multiple different ways to do that logic, ReSharper will tell you, and I'll be like, oh wait, no, there's like 3 different ways it's actually calculating this value. Maybe this is not a good idea. So in this case, though, it is a good idea because, again, there's only one place it's found that it's actually calculating this expiration date. Okay, so I can go through the same sort of exercises here to say like, okay, well, offer types, what are the different ways you can create this sort of thing? So, I can create a constructor to say, well, you need to have really all of these things in order to create one of these things. And then I can go through and sort of fix my models to make sure that they, at least from the initialization perspective, that I can't create one of these things except through the kind of the required fields presence or required parameters for whatever it takes to create this thing. Now, I am using an ORM with a relational database, so there are often going to be some like minor compromises in a fully encapsulated domain model. That's okay. Like, I'm not a real purist on that. Some people are, which is fine. But I like to just go like kind of good enough, which is like the public API. But sometimes you have to do things like create private constructors or internal constructors or like other, like exposing visibility maybe a little bit past what you want. But from my perspective, that's okay. As long as we get kind of the spirits and the kind of the 95%, I don't really care about that last 5%, personally. All right, so back over here. Now that we've kind of pushed some of the behavior down to our offer object, let's see what we can do with this assign offer method. Oh, I haven't built in a while. Let's see if am I still even compiling? Oh, I do have something that says the date expiring. I've made that private, and so it won't let me actually set that value. I'm going to come back to that here in a second as we fix this other method over here. OK, this method now, assign offer. Now, where should this logic go? I have a few options here. I can look at the incoming parameters to see if they should belong there, or I could look at any kind of domain objects created as part of that method. So offer type. Should this logic belong in offer type? The way I can look at that is looking at the usages of that parameter and see right now, there's only one usage of that offer type, and it's passed through as a parameter to this offer object. So that's probably not a great place for this method to live. I probably don't want to move this logic to offer type. Even the name of it, I'm assigning an offer. Does that have anything to do with offer type? It's just used as part of it, but it's not the kind of primary focus of that. The next is member. So here, if I look at usages of that parameter, I can see that it is used in the creation of the offer object. And there's also some mutation going on over here with the member object, where I am adding an assign offer and then incrementing the number of active offers. So I see two usages there. Finally, I have this offer object itself, where it is kind of newed up, passed through, and then returned in order to facilitate persistence. So here I'm like, well, it is newed up, but then you're not doing anything else with it. It's really the assigning of the offer to the member. That's where I see the actual behavior here. And I'm actually mutating that member object itself with a number of active offers thing there. By the way, you probably shouldn't do this kind of logic, but that was the stupidest thing I could think of to illustrate also doing some other mutation. But in any case, it looks like I'm doing more with the member than I am with the offer object. So in terms of where this behavior should belong, it kind of looks like the member object is a good place for it to go. So again, I go back here and I say I want to refactor this, in which I'm going to, instead of saying like, well, let's move this method or whatever, I can say make this method non-static. And I'm selecting the member parameter. It won't even let me pick int because I can't modify that type, and also int, that doesn't make any sense. And so yes, I can see that basically I have these two options in order to choose from. So member looks like a good choice here. So let's go ahead and do that, and we'll see here that it has modified the initial logic here to say just member.assign offer. And now that's it. So all the main logic has now been pushed down into this assign offer method here. So in this assign offer method, we are mutating the assign offers and then incrementing the number of active offers. And then that basically is now the extent of this logic here. Now we have some funny things that we can do as part of this. Like we can do things like assigned offers.clear. And so, if I showed this to the domain expert, we're like, can you just clear out the assigned offers for a member? They'd be like, no, you can never do that. That means that they come to the login on the website one day, they have a bunch of offers, and then the next day they're all gone. That doesn't make any sense. And so right now, our public API of the member object allows us to do way more things than we really should allow it to do. And so I want to kind of fix a few of those things. So things like, what does it take to create a member? We need to have a first name, a last name, and an email. So let's go ahead and create a constructor to take those items. So I need a first name, a last name, and an email. I would probably need to fix all of the compile errors as part of that. But the really one, like number of active offers, this should be private, should not be public here. And then right now I've got this list of assigned offers. This should not just be a list that anyone can do anything they want with. Instead, what we want to do is encapsulate this collection. And so that's another kind of just kind of stock refactoring, is to, instead of exposing out everything here, is to encapsulate this collection behind a private field. So I'm going to, let's see, to property with backing field, yes, there we go. And then now, instead of me allowing anybody to do anything with this, I'm going to remove the setter because you can't do that. And then this is going to be, I would probably just make it an I read only list, because that gives me kind of the reading ability of this, but not the mutation part of it. And so now inside my method, I can just say, use the private field as opposed to that public property there. Now, my original method still compiles, right? It says assign offer. It's still good to go. At this point, though, I may have some other code that is not compiling. So if I look at that, I can see, oh, nuts. I've got this other set of behavior that is also doing some work, and it was mutating that object. So we're going to go follow the same procedures we did before to figure out which should this behavior belong. So I can look and see that it's doing some data access. That's kind of the first part here, is going and getting the member object. It's then in looking to find the individual offer object itself, and then doing some mutation. So looking at this, I can say, well, why don't we go ahead and extract a method for the kind of the business logic-y part of this. And this will be expire offer. And then now I could move this method over to the some other destination here. There's one problem, though. It's using this request object. So what I'd like to do is extract a parameter for the things that are using inside of this. The only kind of interesting thing that's going on here is that there's a offer ID and a member ID. And the only thing being used for this request object is the offer ID. So what I'm going to do is extract a parameter for the offer ID. And it tells me that this request object can be safely removed. So now it's just going to be a GUID of the request offer ID. And I'm going to call that offer ID. And now I can expire this offer. So this method is now static. And so it's not using any dependencies. And because of that, now I can make this method non-static to push this behavior down into my domain model. I select the member object, bloop. And so now this, this service class is just data access, domain model, data access. And that's really where I like to get to, is just like very concise, data access, and then all my behaviors push down into my domain model, which can include, of course, domain services. So down here, let's see if it worked. Oh, didn't quite work. So we're going to do the same thing here, where we'll extract a method here. We'll say extract a method called expire, and then refactor this method because I can't mutate that private property. So I'm going to say make this method non-static, where now it says offer.expire. So with this, if I go back to my assign, this looks like probably as good as it can get. I could, if I wanted to, push down this offer value calculator usage down into my domain model. Usually like half the people love it and half the people hate it, of aggregates calling out to domain services to do their work. I don't really care. It's like more of a team preference about what they like, what they don't like. So we could, if we really wanted to, move the usage of that down to this method, but then my scores of the talk go down, so I'm not going to, but you could if you want to. Otherwise, the kind of like very isolated behavior of my domain model is now fully encapsulated inside my aggregates and my entities, which means that one, my domain model is actually unit testable now, like the business logic is inside of there, and now my domain model represents that fully encapsulated domain model ideal, but I used code smells and refactoring techniques to arrive there versus trying to guess it up front. So just kind of close this out. I'll go back to my presentation here. Boop. So when I'm kind of coaching teams through this kind of domain modeling initially, I do often have them say, like, don't necessarily from the get-go try to follow these very, very rigid sort of ideals of a domain model. Do try to start out with the most boring code that can possibly work, the kind of red-green, and then leverage code smells and the idea of moving towards a domain model to use those refactoring techniques to push that behavior down where it should go based on the behavior that we see, not based on the behavior that we guessed somewhere else. So if you want more information about this, these are the two great books that I recommend to be able to craft and hone those techniques. Otherwise, I'll be hanging out afterwards for questions. And have a great rest of the conference. Thank you.